Okay, I'm going to try to pick up the pace here in the second video. We flipped the page, and we're still on the Analyzing Spectrum lecture tutorial. And what we see is a curve here. And this curve is not unlike those dark line spectra we were looking at on the previous page. It's the same information. The difference being that on our x-axis we have wavelength. So we're seeing the different wavelengths of the light. Again, the way this is set up, you have the lower wavelengths, the shorter waves on the left, and the longer waves on the right. So we essentially have blue on the left, red on the right. And what we're also seeing is the intensity of these different wavelengths. So we're seeing the energy output, or the amount of energy, let's say, received from that star at these different colors. So it's the same thing. We're getting the same information as the dark line spectra. The difference being, we essentially know that not only are we receiving, let's say, some blue light and some orange light and some yellow light and some green light and some violet light, all that kind of stuff, but we're also learning about how much of those different colors of light we're getting. And so that's where you would see the light the color that you're getting the most of would be the peak of the curve. Notice these little dips here. Those are where you have those dark lines, where you're not receiving light of that particular wavelength or that particular frequency. And that's what shows up on your dark line spectrum as the dark lines. So, getting on to question number 4. They want us to compare star A with star G. And they tell us that star A has a temperature of 30,000 Kelvin compared to star G up here, which has a temperature of 25,000 Kelvin. And it asks us, do these look correct? And what you should have learned was that from that Wien's displacement law, that as your temperature of the star increases, the wavelength at which the curve should peak should move to the left. And sure enough, that is the case. If you kind of drop down from the peak of G, it is in 1, 2, 3. You can look at these little tick marks on the x-axis and notice, okay, it's just past the, let's see, 4th tick mark. Whereas on star A, the peak is a little bit to the left of that 4th tick mark. So that indeed shows us that the peak of A is to the left of G's peak because A is the hotter star. Now number 5 says, are the absorption features, these little dips on star A, drawn at the right wavelengths? Well, you can look back on your previous page and look at star A, the dark line spectrum of it. There it is. And we see that with star A we should have 2 absorption lines on the blue end, 2 essentially on the right end, and then 1 kind of in the middle. And sure enough, on our spectral curve, we see that. We see 2 dips on the left side, which is the blue side. We see 2 dips a little bit farther spaced apart on the red end, and then we have 1 in the middle. So sure enough, this looks like a proper representation of the dark line spectrum. Now, moving on, we've got a bunch of different graphs here, and I've actually drawn these in for you. But we're supposed to sketch the spectral curves. And so, A, we've already, well, star A, we essentially already talked about, where we have 2 on the blue end, 2 on the red end, 1 in the middle. Now, again, you do the same thing. Notice that mine, not only do I have, I try to sketch in my little dips for these different stars. Remember, star B and C and D. But I also try to make my peak correspond to their temperatures. Remember, we said as the temperature goes down, my peak, wherever I peak, it should be to the right of, let's say, star A. Star A was the hottest star of the bunch. Remember, it had a temperature of 30,000 Kelvin. The next hottest was star F, and then star B, etc. So I would expect that my peaks should occur farther and farther to the right, depending on the temperature of the star. So that's what I tried to do. I love a little dashed line here. And I also tried to then put little dips where the absorption lines occur. And notice also, some of my graphs are taller than others. Why is that? Because we learned from that Stefan law that the area under the curve is indicative of the temperature or the energy output of the star. The cooler the star, the less energy it's kicking out. And therefore, it looks like star E or C is among my coolest, and so sure enough, I drew, in fact, it looks like star E is my coolest. So I drew my peak farthest to the right, and I also drew the height of my graph fairly low. Question 7 says, Did you draw the peak intensity of each spectral curve at the same wavelength as the spectral curve for star A? Absolutely not. The peak will shift to cooler wavelengths for cooler stars. And number 8, they say if you were given a star's absorption line spectrum and its corresponding spectral curve shown on an energy output per second versus etc., how could you approximate the temperature of the star? Well, you would use that law, that Wing's displacement law. We played around with it a little bit when we looked at those discharge tubes in lab. Essentially, the relationship is when you multiply the temperature by the wavelength of your peak, wherever your peak is, whatever that wavelength is, if you multiply the temperature and the wavelength, you should get a value of 3 million. Or another way of doing that is you can get the temperature by dividing 3 million by the wavelength of your peak. And that'll give you the temperature of the star. A little bit inside baseball. I'd much rather you understand why the peak shifts and why the area under your curve is either larger or smaller. Don't necessarily have to focus so much on the math there. Now look at question 9. It says, we got a student who makes this statement. It says, if I'm looking at a star's absorption line spectrum and see that it has a lot of lines at the blue end of the spectrum, then the star must be hot because the blue lines are higher energy lines. Do you agree with them? No, you shouldn't. Because again, as we talked about, if you just have a dark line spectrum or an absorption line spectrum, the only thing it'll tell you about is the composition of the star. The absorption line spectrum does not give you information about the temperature because we don't know the relative intensities of the colors that make up that dark line spectrum. And one thing you can do is consider stars C and F from the dark line spectra. Star C is cool, and yet it's got 3 lines on the blue end, whereas F is hot, but it has 4 lines on the red end and only 1 on the blue end. So essentially, that contradicts what the student is trying to say there. So that's where I'll drop it here. We're about 7 minutes in. I'll continue with the rest of the worksheet on the next video.